What's going on, y'all? It's Daniel Litwin, the voice of B2B, and welcome to another episode of the Rugged Edge Survival Guide, a Premio podcast, and it's a special one. We are live from Austin, Texas at Embedded World with the best-in-class companies that are powering the future of embedded systems, right? The hardware, the software, the tech ecosystems that are transforming specialized computing and industrial automation, agriculture, transportation, everything in between. And we're ready to have some great conversations here with the Premio team and Premio's partners. So, welcome to the show. We're joined here today by the one and only Dustin Seetoo of the Premio marketing team. And we're also joined by the Kingston team. We're joined today by Mr. Mark Noland and John Terpening. Mark, John, welcome. How y'all doing?
Great.
Yeah, welcome to the show. So, as you can see, we've got ourselves a little panel to kick things off. So, with our Premio and Kingston panel here today, we're going to be chatting a bit about the Kingston-Premio relationship, but more importantly, how that relationship reflects some key trends that are shaping edge computing, embedded systems at large, and the use cases that they're powering in some key industries. Let's start off with some basic intros. We kind of already know who you are, but why don't you give us a refresher on Premio and especially in the context of embedded world, why is Premio here today?
Yeah, sure. So my name is Dustin Seetoo, Director of Product Marketing. Been doing this for about 12, 13 years. Extremely excited to be in the industry because we're in this new age of accelerated computing. All this technology is coming to the forefront. What that is doing is bringing a lot of this autonomy, a lot of machine learning, a lot of AI. But who Premio is and why we've been in business. We've been in business today is actually, or not today, but this year is our 35th anniversary. And with that 35th anniversary, we have built strong capabilities in our design, manufacturing for our core computing products. Our core capabilities are all built around our ruggedized computing. As you can see in our slogan, it's built rugged, built ready. And what we do with those is that standardize all these product offerings to deliver strong product portfolio for key architectures in our computing technology. That's from x86, now NVIDIA Jetson, and with those core technologies, with our partners, obviously, we're pushing forward to a new age of accelerated computing. So we're extremely excited to be in an embedded world with our partners, and only more to learn and see in the world of compute.
Well, we got built rugged, built ready, and the Kingston team built on commitment. So a lot of building going on here at this panel. So again, we're joined by the Kingston team. They're a memory and storage tech company. They have obviously consumer, but also commercial and industrial applications. But I'll let you all do a little more in-depth of an intro here. Who does Kingston serve? What are your core competencies, and why are you here at Embedded World today?
Mark Noland, I'm the technology manager for embedded SSDs.
Nice.
And so on the SSD side, for Embedded World, it's a kind of smaller fraction. So that's like your pre-built SSDs, M.2, 2.5 inch, even some older form factors. But the real star is John's products here with the embedded memory and storage products that you're going to find in all of the things that are soldered down to motherboards.
Nice.
Yeah, John Terpening with the Embedded Group. So for us, embedded is anything soldered down. I manage the engineering department for that. And Kingston overall, memory and storage is the focus. So we have all these different segments. Our Embedded Group started probably around 2010. And it's been growing significantly, especially with the IoT and the onset of these application processors that have more horsepower for the embedded applications.
So what I love about Embedded World is that you get a full scope of the ecosystem that is powering the future of specialized computing, right? You have the Premios of the world, who are the edge computers, right? That are the engines at the edge. You've got the Kingstons that are providing the under the hood, memory and storage to handle powerful use cases. And then you've got the whole ecosystem of IoT devices, of other embedded systems that, like Edge AI, make these use cases intelligent and intersected into larger ecosystems of data capture and operations. So I want to start to unpack that whole ecosystem with y'all and get y'all's perspectives from the memory and storage side and from the edge computing side. why is this embedded market segment so important for your businesses, right? And how does it fit into some of the trends that you're seeing shape specialized computing?
Yeah, I'll take a stab at that first. So I want to keep it within scope, so I'll speak within as an OEM manufacturer of compute.
Sure.
So for 35 years, I think you've seen ebbs and flows of this industry go up and down. A lot of this is built around compute, right? So if you look at the key word of what this show is about, it's about embedded compute. So what that really means is, what are you embedding into a lot of these machines to drive the next level of processing, storage, connectivity? But with each generation of technology, you're getting faster, you're getting better, lower latency. And that's why today I'm extremely excited. I think the industry is excited to extremely grow because you have this explosive growth, right? In the last decade, you've had these key trends, right? John mentioned this, IoT, right? You have cloud compute, but where embedded computing is now going into is what we've defined as edge compute. And why edge computing is so important is because this is placed in what we defined as the edge continuum, right? And within the edge continuum, there's so many different technologies that are, like you mentioned, that are working like an ecosystem, right? We are working with Kingston because they provide a value in some type of embedded memory or storage that provides value in our computers. But within that edge continuum, right, when we talk about the technology, when you move that data from the cloud to the edge, it's very, very important to understand what your product is, what your technology is, and how it's positioned in the edge continuum.
Yeah.
And as we spoke in our kickoff of our webinar and our Rugged Edge webinar, we as Premio defined our own buckets and how we are positioned in the products and specific trends that are making it important, right? So with that said, right, at the edge continuum, when we move from the cloud to the edge, we have the user edge. And within the user edge, we have defined that there's the industrial edge, the rugged edge, and specialized edge. And those three buckets, there's key trends that are defining what that is, right? A lot of edge AI, right? 5G technology, OT to IT convergence. So these are the fundamental, I would say, technology catalysts and drivers that are allowing the ecosystem to now put forth their best technologies, package that product together to deliver an applicable solution that's delivering real-world problems, real-world insights.
Yeah, love it. And I mean, y'all being on the memory and storage side of things, and also the fact that you serve commercial and consumer and industrial applications, that gives some unique insight into, the embedded world is just one slice of your pie. So how do you see this market segment, in comparison to growth and changes in some of the other markets that you serve? What's unique about some of the energy behind innovation and growth in the embedded systems ecosystem?
So on the SSD side, consumer SSDs, capacities are going up it seems like every month. There's new generations of PCIe that are coming out. In the embedded space, things move a little slower because people don't want to throw out new technologies that aren't thoroughly vetted, because you can't put an edge computer out somewhere up on a pole or in a train car or something, and with technology that hasn't been vetted and that's not mature. And so a lot of the things in the embedded space tend to be a little bit more robust, things that have been vetted for quite a while. So one of the big differences with SSDs, for example, is that consumer SSD that might come out with the latest features and everything, big capacity, the industrial SSDs, they lean towards having a long lifespan because as a product, because when we come out with something, even before somebody can put an SSD into an embedded system, they have to test it and vet it through engineering, and so it gets qualified, and then they might have like 2 to 5 different SSDs that they qualify for a system, and then that product has to be manufactured, and that might be an 18-month period of time before they even get a product out the door. And a lot of consumer SSDs, that's like twice the lifespan of some consumer SSDs, right? They'll come and go quickly, where industrial SSDs, they have a lifespan between 2 to 5 years for some products. The embedded side is in that way too, right?
Yeah, so prior to some of the managed NAND solder down solutions, it was all ruled by the microcontroller. Around 2009, the eMMC spec came out, and that's where we entered the market. So over the last decade, the IoT space has grown significantly. It's been powered by, one, the availability of connectivity, so at the edge. And the other side of that has been increased processing power with the application processors, and those require external DRAM and storage. So we've ridden that wave, and it's been a tremendous amount of growth over that last decade. Looking forward, we see more growth too with emergence of 5G, AI starting to make its way into products, and a lot of connectivity outdoors besides 5G with all the satellite communication systems as well.
And y'all are kind of mentioning this in your answers, but there's a unique kind of give and take here with this industry where the technology sometimes outpaces what the industry is ready for, but at the same time, we see so many innovative use cases for edge computing today, and I mean, we see them here listed on the Premio booth, right? In IoT, security and surveillance, intelligent transportation, industrial automation and robotics, rugged edge AI, and so I'm curious if y'all could talk a little bit about who's kind of leading on that push and pull, right? Do you often find that the use cases are guiding new developments in your embedded systems and your edge computers, or is it the other way around? Y'all are often looking ahead at what is the industry going to need. You prep the technology, and then once it's ready, you go to market, you launch, and you start to plant the flag. Kind of who's leading on that push and pull?
I think it depends.
Yeah.
I think it depends on who you're talking to. So like as a component manufacturer, Mark mentioned this, is that you have standards that define speed, latency, performance, right? So when you're kind of including those standards are always going to be moving faster because standards dictate technology. Standards allow multiple people in the ecosystem to adapt and evolve, right? But speaking from an OEM system builder, my perspective is that you really have to pay attention to the system builders, because the system builders invest a lot of resources in engineering, qualifying specific drive components to put into the box. But it's not just that, right? It's laying down the PCB, the PCBA, the entire chassis, pushing it into certifications, right? That's why we do all the certifications from SUC, CE, even UL across all our products. That's extremely important because we have to basically digest what's evolving in the technology space, decide if we want to incorporate it, but also deliver a solution that the customer wants, right? For example, some people can say, I'm going to make the best, fastest, but the most technology into a product, but it's too early, right? There's no adoption of that, and then you're kind of missing that. You're missing that hype, right? You have to catch that time when the opportunity is right, and to kind of speak to that, right? A lot of the technology that you're seeing on AI, right? Generative AI, and a lot of what NVIDIA is doing in terms of their AI and machine learning, extremely highly performance. I think it's great on what they're doing, but in my opinion, it's still kind of in a hype cycle, right? Hype being that we're still about 5 to 10 years out. And I think you really have to pay attention on what the system builders are doing in terms of an application to deliver for our customers.
Right.
And what we do is we actually listen to our customers, right? Listen to their pain points, better understand what they can do. So when we move to the next generation or iteration of our design, we make sure to put that into the products. Also working with our component vendors to better understand what's on the technology space, and then putting together a solution that's marketable, right? That's fit for specific market verticals like industrial automation, security and surveillance, IoT gateways, intelligent transportation. And that's our goal.
Love it.
Well, we rely on our integrators, people that are building systems, to basically let us know what they need.
Yeah.
And so, we work really closely with Premio and folks like them because they can tell us where they're going. We share roadmaps with each other. And so they know where we're going, and we know where they're going, and so we'll use them to get guidance, over future products. So if we, get enough weight pulling towards something we're not doing, we have to start moving on doing that.
Yeah, basically we got all bases covered, from solder down, small scale eMMC down to 4 gig for some of the lower power processors, all the way up into UFS on the solder down side, and then other SSD type of technology, and all the memories covered. So we take it to ruggedized and industrial temp, higher temp. So whatever environment, whatever amount of storage or memory they need, we're there.
So for embedded memory and storage, especially with some of these more advanced edge use cases, is there ever too much storage? You'd think that it's like the more the merrier always, right? But I'm actually curious about that. Like, how much do you have to actually kind of hold back a little bit to keep storage in line with the actual use cases versus just kind of building out a few years ahead, knowing that the use cases are going to get more data intensive and there's going to be more edge processing and storage to have to account for? What do you think?
On our side, yeah, there are a lot of applications where all they need is a few gig to run a small Linux OS.
Right.
But then it can scale depending on the application. So
just give them a terabyte.
Yeah, exactly. And so we can. That's why we got the SSD side of things.
We've got one group of engineers saying I only need 128 kilobytes.
Yeah.
And another one saying I need 16 terabytes,
Right.
And so it's like
you got to find the balance.
Yeah, yeah.
Broad market.
Yeah.
We can cover it all.
So I would define it as a system builder. It's important to really narrow it down to the cost to performance ratio, right? It's the cost per dollar, because the investment that you put into designing the product has to have a return. So again, like, you can do the fastest or you can do the best performance, but if it's extremely expensive, what's the return? Does the market need that? Does the market not need that? So as a system builder, we have to evaluate all these different things. And how we evaluate it specifically for edge compute, there's 4 key attributes that define an edge computer that we have to actually take into account to associate the cost per dollar, right? So everything from performance, energy, space, weight. These are the 4 key attributes, if you really are looking at the design of a computer, allow us to actually win with our customers, but allow them to succeed in their application. So for example, we have a customer here in Austin. They do a lot of the autonomous forklifts, right?
Cool.
And how they actually looked at our computer were some key defining features. Processing was important, I/O connectivity performance, GP acceleration for the machine learning, AI and inference detection. But you know what helped us win? The space.
Really?
It literally was how we designed the chassis, how we made the space. Our heatsink design allowed us to actually move that product, and they were very grateful for that mechanical design. So 4 key attributes of edge computers are very important, not only for the ecosystem, but those are the things system builders are paying attention to.
Yeah, and that makes sense to, I mean, when you're investing in an edge computer, usually, I mean, you could tell me if I'm wrong here, but I imagine you're not just buying usually one edge computer. A lot of these use cases are you're deploying a fleet of them for something like, let's say, a bunch of forklifts, or for smart or intelligent transportation ecosystems, or edge computers at the edge for energy infrastructure. I mean, that's usually not just one computer in one location, but you're thinking about an ecosystem of data capture. And so when you then bring in the question of what storage is right for that, I mean, yeah, the extra 1, 5, 10 terabytes, the cost scale on that starts to be significant. So fine tuning, I imagine, is more per use case around the cost, around how it's actually going to relate back to what are the returns on this investment.
Yeah, and just to kind of comment on the embedded space. So Mark mentioned this as well. The embedded space does move a lot slower. Slower in the sense doesn't mean it's worse. Slower in the sense that the adoption of technology is a little bit slower, because the mass deployment of real applications is still on that technology. So a very good example would be in storage based on SATA protocol versus NVMe, right? So on the consumer space, I'm sure Mark can talk about NVMe all the way, PCI Gen 5 speeds, all these type of latency, lower latency, right? But really on the embedded space, quite actually, some applications or most applications are still okay on SATA at that 6 gigabit speed, right? But then if you go into NVMe, we are starting to now see NVMe be more prevalent on the soldered down board, right? And that just is natural evolution of technology, right? But embedded takes a little bit of time, right? It's the applications are a little more rugged, so requirements are a lot more. So wider operating temperature, shock and vibration, power input, all those things are what's valuable for edge computer.
Yeah.
And what we're doing as Premium, what we've been doing for the last 35 years in designing computers for this specific space.
The bandwidth for an NVMe drive is minimally like 6 times faster than SATA. The latency is thousands of times faster than SATA, but in a lot of cases, your storage in an embedded product is basically being used to hold the firmware and like a Linux kernel, like the OS. And once that OS gets loaded in memory, it doesn't really go back to storage. There are some things that are I/O intensive if it's recording video or databases or giving some kind of feedback on the edge where you might need like low latency, high speed NVMe storage. But even in that case, right now, I think PCI Gen 3 is probably the standard on the edge currently, and moving to 4. Gen 5's out there in the commercial world for gaming systems, but we'll let the gamers fall on the sword to test that out and make sure that that technology is vetted before we start throwing it into a machine that you put out in the field and leave it for 5 to 10 years.
Yeah, right. Yeah, let it get tested in the rough waters of running Elden Ring or something, right? Yeah, I got you. So, okay, let's talk about major trends, right, that are shaping some of what we're talking about here. The push and pull of unique edge computers, of unique embedded storage and memory systems. I'm curious what y'all see as some of the most pressing trends, and really more importantly, related to use cases, right? Industries and market segments that you see as the ones driving innovation. Often I find that single market segments end up creating almost like a bleed effect where their innovation actually starts to open up new doors of possibilities for completely unrelated market segments that could use similar solutions. So where is the innovation really being spearheaded? In which industries and market segments?
As I said, the last decade's been propelled a lot by the IoT indoor, and then things are getting connected outdoor, so that's expanding out there. AI we're seeing as a big fuel the next surge, and it might be, like you say, somewhat in the early days. We're in that hype cycle portion of it, but we have down back to the integration. We're seeing a lot of the wearables coming in late next year, 2025, 2026, that integrate a lot of functionality that you couldn't have before with AI. So to that point earlier of everything getting shrunk down into smaller space, they're fitting a lot of horsepower in just a little space, and AI has been very demanding, obviously, both on the processing, a lot more memory, a lot higher speeds, and we're able to get that into small devices, integrate both storage and memory into a device. So I think you'll see a lot of the edge computing again continue to get smaller and more powerful, and fuel a lot of applications, endless amounts.
I think too, as the data centers grow, like as the the latest NVIDIA GPUs get rolled out into data centers, and it creates a draw for the need for more data from the edge. And so I think as the data centers grow and expand, the edge is going to grow exponentially relative to the data center. It might be 10 to 1 or 100 to 1 or 1,000 to 1 for every compute node that goes into a data center in the next years. There will be thousands of compute nodes going out on the edge to collect data, and like from your set-top box to the switch on the pole outside your house that's streaming video and internet, et cetera, and collecting data from cars and trains and buses and airplanes. It's sort of growing at an exponential rate.
Yeah, so I think both of them mentioned some very key points. I think the takeaway that I'm hearing is this data explosion. And this data explosion is coming from so many different devices, and those devices are stemmed to a digital transformation of some sort.
Yeah.
So when we talk about digital transformation, what's extremely happening is this level of new age intelligence, machine learning models that are moving out from the cloud out to the edge, and that's where you're able to do the real decision making, right? So I would say some of the biggest trends, and I look at a lot of market research all the time, so a lot of the leading market research will say like 75% of data is going to be processed outside the cloud and at the edge, right? 75% of data is a lot of data, right? But what's the reason for that, right? The cloud is never going to go away. There is a symbiotic relationship between the cloud and the edge, but there's value at the edge because that's closer to where the IoT devices are, right? So by like 2026, 75 billion IoT devices are going to be coming online. Right, and all those devices are now pinging data. And when you have that data, you have machine-to-machine intelligence, right? After the model or the neural network model has been trained in the cloud, it gets moved out to inference. And that inference detection is where you're seeing a lot of this new age applications happening, right? So you have industrial automation for autonomy, you have robotic arms, AGV, AMR, these things moving all through the factory floor, using a lot of computer vision technology on the back end with our compute modules, right? Security and surveillance. Before you just had dumb video feeds and you had a human actually sitting there looking at the video footage to do the security and surveillance. Now you can use analytics, overlay, right, and actually put the data extraction on security and surveillance, right? Intelligent transportation, you have like railway, you have intelligent public buses, all these are kind of tapping into this new age of edge compute, right? And where each of our customers are very important because they're in their own digital transformation, right? So it's important to recognize what we're doing with them, but most importantly, what their challenges are to help them evolve and move to that growth in their transformation and what they're looking to deliver, right? And I think that's it's very important to understand within the ecosystem, like we're all working together for that one goal. Right? Without partners and memory and storage, we wouldn't be successful. Without compute, our customers wouldn't be successful. So I think as you go through the supply chain, everyone's working together to actually deliver a solution that can solve real world problems, and that's the end goal.
Speaking of solutions that solve real world problems, what is an example of a Kingston Premio partnership out in the field today that you think is really capturing that mission of fitting into a larger digital transformation for that industry, solving a real problem, and helping to set new standards for how data can be captured, processed, and what kind of operational benefits that brings to that industry?
Yeah, so I can speak to that first. So let me kind of speak to our process on kind of validating, memory and drives that are ruggedized and important. So with Kingston's iTemp series, right, they were added to our AVL because they were able to meet the qualifications for wider operating temperatures, right, meeting the shock and vibration. And what that allows is that allows us to put our built rugged, built ready promise and commitment to our customers that when we put those components into our computers, that is just as important as the entire system being reliable, right? When we meet these specific regulations from UL, FCC, CE, we need to make sure the entire platform is reliable. So one application specifically that I can think of that was very important was intelligent tolling. So intelligent tolling being as cars go through the tolling system, they're doing license plate reader. It's in a rugged, remote environment. Oftentimes, it's not accessible. So in that sense, they were able to leverage iTemp drives, M2 SSDs, 2.5 inches, well, working with our x86 compute architecture to kind of drive forward that unique application for Edge AI.
That's an awesome example of it. We're in the terms of embedded. We're just rolling out our iTemp, higher temperature tolerance SSD devices.
Nice.
And the reason that we did come to market with the product is partners like Premio, saying, hey, we need iTemp, we need higher temp support, and back to our motto is we are built on commitment to supply what our partners need. And there, that market is definitely growing as the edge expands out. Like you're saying, replacing sort of passive systems with active systems for monitoring and safety.
Yeah, definitely. As you get more applications outdoor, we're seeing growing need for industrial temp, automotive temp, higher temps, or the extremes down on the cold side as well. So that's only going to grow more as, again, we get more connectivity outdoor and more processing power for these systems to make independent decisions, localized as well.
Well, that kind of open real-time dialogue between y'all as partners and then keeping a listening ear to the actual solutions that customers and industries need is going to be key, obviously, to stay on top of these rapidly changing market trends, even if the embedded world moves a little slower and the industrial world moves a little slower in terms of new technology adoption. I have a feeling that pace is just going to keep picking up as you get key repeatable use cases solidified in each industry. Then you see the money start to talk a little bit more, and then it's about deploying at scale and releasing products that are future-proofed too, right? And so with that in mind, my last question for y'all is, what do you see on the horizon, right? What are some of the things that you're designing your products and solutions around with future-proofing in mind, especially, I guess, around some of the challenges that you imagine will hit specialized edge computing as these use cases mature?
Yeah, so let me kind of speak to where we are in AI. I think we are in a hype. Reason being is in a lot of the market research, I call it the 3 Ps of where AI is, or just kind of in the evolution of AI. So the 3 Ps in my mind is you have the planning, the actual pilot, or the proof of concept, and then pilot, right? And majority of the customers that are looking into AI are stuck in these phases. So stuck, why are they stuck, right? Obviously it's still early in AI, but they're looking for help within the ecosystem, right? And the ecosystem, what's very important, because the ecosystem, like I mentioned, drives technology, it drives innovation, it drives solutions, right? So with that, I think we're still a ways out, specifically for AI, but where we're starting to see real world applications come into play is what we see on the OEM system builder side is the edge computing and the computer vision. Both those are key markets that are driving the processing, the I/O connectivity, faster storage, and lower latency with 5G on the horizon. So what you're starting to see more of is that you're going to start to see definitely better processing away from the cloud, closer to IoT data, and that data is where you're going to have the machine-to-machine communication, and then you're starting to deliver automation, right? Remove the human element to deliver the situational awareness where the machines are able to now make some type of decision without the human to have that element. So automation is a huge major market, right? Manufacturing, security and surveillance. These are some of the markets that we see as a system builder that are explosive.
Yeah, I would agree. We've been deployed in vision-based systems over the last decade, and they're just getting better. And I think the industry understands how to use those. It's going to be other capabilities that come out to the edge and at the device, and you'll take a year or two for them to figure out what exactly is needed there. But again, it's a trend forward, and it's going to be exciting to see a lot of the processing power moving out of the cloud and getting done at the edge. For sure, definitely.
I think on storage and memory, it's a little more simple than the systems in that it'll basically be larger capacities, higher bandwidths, new PCI buses, as new technologies roll out. But it's not quite a glacial speed that it moves at, right. But it does progress, and every year, there's more vendors that move to a new PCIe bus, and they're willing to consider it tested well enough to like put it into production. And we're always doing faster bandwidth on memory, faster speeds of SSDs, bigger capacities that roll out. But we try and be conservative so that those products can also have the durability and longevity that they need in the embedded space.
Yeah. Well, and I guess that speed of movement too, it gives you all the ability to accurately anticipate what the market's going to need and build solutions accordingly, right? And I think with the kinds of partnerships that y'all have, where you can learn from what different use cases and different markets and different customers are asking for, you'll always have a pulse on what's most needed now and also what's on the horizon. So I'm excited to see how partnerships like y'all's continue to guide the industry forward and help deliver on some of the most innovative edge and specialized computing use cases for all these industries, from IoT to security to industrial automation and transportation. I mean, the ceiling's pretty high, so it's gonna be cool to see all of this in action. All right, well, thank you to the three of y'all for this panel. It was great getting to learn from you today. Again, folks, we were joined by the Kingston team with Mark Noland and John Terpening, and of course, Dustin Seetoo from Premio. Thanks again, folks, and we'll catch you on some more live interviews here out of Embedded World at Austin, Texas. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on some more episodes of the Rugged Edge Survival Guide.